Hello, everybody, and welcome to. We have actually have some prep hashed podcast, where obviously we prepare our episodes, so we have something to talk about.
I don't have
How was
anything.
your week? How was your week, Jeff?
No, I'm not going to answer that. Oh, you really want to know? Is that the prep? My week was. I
No,
was trying to find a bug in the program for the entire week on a Zebedee thing. Yeah.
okay. Um, and it appears we're actually playing StarCraft now with a group of people. What's going on over there? Who are these people?
Well, you are one of these people, and I am the other one. No, there are some other people. What happened was that that guy UTXO he made a post on Nostr about he posted a screenshot of the first StarCraft, uh, a screen from the StarCraft game, and I comment there and said it was the best game, something like that. And he wanted to play me. I played the one against him, and then he said some other guy interested in playing, and I also knew another two guys that were interested in playing, so we made a Telegram group. And now we have matches almost every day, and they're casted live for the
Yeah,
entire world to see. They're very,
amazing.
very bad matches, but
It's almost as popular as this podcast. Which is like it's about StarCraft, so obviously it's very popular. Um, okay, so if you like to play StarCraft, Brute War, then I don't know, contact fiatjaf
yeah,
via one way or another,
yeah,
and come join the group.
we make a special prize for you, listeners of this podcast, to be able to join the group.
Special prize, special prize for you, my friend. Okay, so I heard you prepared like 15 topics for this episode.
No, you did. I don't have
Oh,
any
uh,
topics at all. I even didn't want to record this episode today, but you said you have a lot of topics, so I can't imagine what topics were. Nothing happened.
okay, so well, okay, so I have two topics and they're aligned.
Mm.
And the first one is that so we sort of went moon. Well, the price went up a bit, and apparently there's all this the institutional money is coming, right? We have BlackRock, and I don't know what the fuck's going on.
Well, there's
Anyway,
Intel too, right? According to the last episode.
yes, and the Intel is going in heavy into Bitcoin. No, so I started wondering. It's like, okay, let's assume that we're going to have another bull market, let's say in a year or something after the halving, or in 1.5 year,
I was
one and a
thinking
half years, whatever.
we should revive that chart stock to flow. I think it will work now. We should.
This time is different. Um, no, but assuming that we're going to have like another bull period and all the craze that's going on with it, I wanted to ask you, it's like, what do you think is different? What is going to be different this time as opposed to last time from a Bitcoin development perspective? Because and the reason I'm asking is I think I see two things. I think the multi-sig stuff has matured to a point where I think it's going to have some broader adoption this time. And I also think that Lightning has matured, where it's going to have some more broader impact, or it's going to be a bigger phenomena than it was last time. And I was just wondering how what you think about that.
Multi-sig. Yeah. Well, I think when I started following Bitcoin, there were already multi-sig. Multi-sig was already a thing that was doable for normal people. But yeah, I think it has improved. There are more wallets, but I don't see this huge improvement. Like, maybe it's more widespread, but marginally. There's also like I don't know the Lightning stuff. I started following Bitcoin more closely in 2018 because of Lightning. So Lightning is already a very old technology. So and after Lightning, I don't see people getting excited about any other thing. Basically, like it's just like some basic things, but not some huge ways of transacting or anything like that. So I don't see what has changed. No, not I don't think that many things have changed.
But it's different, right? I mean, Lightning. Okay, so you
What
technically
what
had
what
Lightning in
what was the last
2018.
what was the last bull market? I think if you're talking about 2020, when was that? Like we went from 3,000 to 60,000.
Yeah, something like that. Yeah.
Yeah, that was 2020, I think.
We'll have to. I'll look it up. I think it was 2021.
Yeah, could be
Um,
that.
but well, like the thing with Lightning is, I don't know. I think with okay, so I've been going to Bitcoin meetups for many years now, right? And we've had a Bitcoin meetup where you pay your entrance fee with Lightning, and you can pay your beers with Lightning for many years. I think since 2019 ish, something like that. So let's say we've been doing that for 4 years now.
Mhm.
But there, you can't just say it's like okay, you have Lightning as a technical possibility. The thing it's a network on its own. Like it's this liquidity network. It requires a lot of infrastructure,
Mhm.
and a lot of that infrastructure it has been built at least, and it stands right and is functional. Payments aren't failing as much anymore. There generally are routes. There is liquidity in the
I
network.
don't know about that.
Um,
I don't know about that. I think they're working for the big providers. So my experience
yes, but
has
those are
been
the people.
shitty. Oh, and like yeah, it's working for people that dedicate their lives to their nodes, which are very low people, very few people. And I think it was more some years ago.
Okay, but
And also
how
the
many people do you think how many people do you think had an interaction with Lightning last bull market?
I don't know. I don't know, but I think most people will interact with via some custodian. And yeah, and for the custodians, it's working fine. I think.
Right, but that was the point, right? They're I don't care if they're downloading Wallet of Satoshi, they are going to use I think they probably are going to use Lightning,
Yeah, yeah, but
or
that's
get
not
some
yeah.
exposure to it. I think that's going to be on another level as opposed to last time, which was in 2021, by the way.
Okay, so it was not long ago. Okay,
Yeah, that's it. We're
yes.
not,
You said you had two topics.
yeah, it's okay. And the other one is that I did some napkin math that I wanna discuss here with you.
Well, maybe I can understand
Uh,
the last time you sent me the math was it was I didn't understand it at all.
okay, so something that we've been talking about on this podcast a bunch of times is the stuff about the on-chain fees and the fact that you need a certain amount of satoshis. That every transaction that you're going to do on-chain requires a certain amount of satoshis, just in order to justify the fees, if there are actually fees, right? So in a low fee environment, none of this stuff really matters. But as soon as there is some congestion on chain, you get this so-called fee market, and then fees go up. And what actual impact does that have? And I did some napkin math on that to figure out. Is like, okay, um, just taking some assumptions and see how that works out. So um, I didn't do a very thorough full analysis. There is this website that gives you a distribution of the UTXO set, as like what percentage has like 1,000 Bitcoin and like 100 Bitcoin and 10 Bitcoin and 1 Bitcoin and then 0.
So you
0.1
didn't do it in
Bitcoin.
your node.
No. I just took that table. So it's a table, and it has like this distribution. And I thought, oh, like this is an easy start, right? I can just put this in Excel and just do some math on it. And so I looked at these UTXO sizes, and I looked at what the V byte contribution is in a transaction of the inputs, and I started out with some basic assumptions, and I just assumed that it would be a taproot spend, so that's the most efficient way of spending, and I only looked at the input side. So there are a couple of components to a transaction where the fee bytes are going. So you have some overhead, and every input needs to account for a couple of V bytes. And with a taproot spend, I think that's 57 sets per V byte, or 57 V bytes. In any case, I just looked at what would be like the most efficient way to spend a UTXO in a transaction, and that it only has to account for its own it only being there as an input. So all the other V bytes that have to be paid for are
You
are
assume they
going to
don't
be paid
exist.
with other inputs.
Okay, I see.
Just to see, okay, where is the lower bound, right? Because that's what was looking for. It's like, let's first see where the lower bound is. So I assumed like the most efficient thing, and then you only have to account for it being there, etc. And then I looked at like, okay, what would happen in terms of like the dust limit when fees start actually rising, and I got this number of 173 sets per V byte, where at 173 sets per V byte, 50% of over 50% of all the UTXOs in the system are very significantly impacted. Where
So if you get to that number, Bitcoin dies. Is that what you're saying?
no. So because in terms of how many in terms of how much BTC it actually accounts for, it's not that lot. It's not that much, right? It's very little actually. Let me just get the thing. I should have because I said it was prep, so I should have actually prepared it. obviously I did. Let me open the sheet. So I actually have the numbers.
How long does it take for Excel to open? In seconds.
No, it's okay. It's okay. There we go.
Yeah, it was a real question.
All right.
Because I was seeing
oh yeah, maybe we can discuss that later.
You follow my Twitter.
So
account.
we have. Yes. Oh, it wasn't 50%. It's close though. Oh no, it actually is. So there is at 173 sets per V byte, if that was the fee you would have to pay on average, let's say, or minimally, then 26.5% of all the UTXOs become completely unspendable because the value of the fee is higher than the sets that are actually contained in those UTXOs. Those UTXOs are very, very small though.
Why these things exist? These people should die. People who make these small UTXOs, and a lot of these are Lightning channels being closed without anyone wanting them to close. Not a lot of these, but some of these at least. Okay.
It's too small to be a Lightning channel.
No, it's not.
We're talking about we're talking about how many sets is this? So this is 1,000 sets and 10,000 sets.
Yeah, I had channels closing with these amounts only.
Okay, yeah, that's really silly.
Because I wanted them.
There's no further analysis on this, but like one of the steps of further analysis could be is like, okay, what are these types of UTXOs? Are they change?
Yeah, that's a good
outputs
idea.
or what's actually going on here. And so these are very, very low amounts, and they only account for a total of what is that? Let's say 45 BTC. So it's only 45 BTC in total, right? Even though it's like 50% or like
Jesus.
or
26% of the
no,
audio TXOs account for this very small
no, it's
amount of
less.
bit.
Okay, wait. I said it wrong. I'm going
Our
to
listeners are turning off and skipping ahead.
yes, and they're getting very confused because I'm saying numbers right. It's like nobody can follow that. It's negligible in terms of like how much BTC we're actually talking about, but in terms of how many UTXOs there are in the, it is a lot. And
Okay, don't need to say the numbers again. Go to the next metric.
yes, because then there is like another 25%, where it's like account for 10% of the fees, or the fees account for like 10% of the value of the UTXO, which is still like crazy a lot, right?
Yeah.
It really hurts if you're gonna have to spend those UTXOs that you at least lose 10%. And again, this is assuming like the most efficient. It's not even going to be like that,
Yeah.
because none of these are like Taproot inputs.
And you can't very easily plug them all in a single transaction. You would have to do that.
Yeah, and and they're
then
not even paying
everything-
for the entire transaction. They're only paying for themselves, right?
Yeah, but if you take all of
as-
them, put them all in a single transaction, then the rest of the overhead becomes negligible. But you can't do that because
Yeah,
each of these
true.
is a different key for a different person. Yeah.
So, and to put that into a more useful number, is that assuming that the price of Bitcoin is at 100K, that means that this cutoff point of 50% of the UTXOs, that's like $100 per UTXO. And then at $100 per UTXO, you're still paying 10% in fees.
Yeah.
So, and this is where it starts to get real, right? Because that means that that's the smallest unit of accounting that you're dealing with is $100.
Yeah.
It's not like I have $100 in Bitcoin spread in a couple of UTXO. No, you need at least $100 in a UTXO, and then you're still fucked. And I don't know how high 173 sats per VByte is, right? It sounds like a lot.
Well,
It's probably
that's a question I
lot,
always
but
have. Like, if the price of Bitcoin goes up significantly, like against the other goods of the economy, shouldn't a smaller sat per byte fee be enough? Like, we don't have to go very much up on the sat per byte as long as the Bitcoin price increases, or do we have to?
Yes, but this is an interesting question. So, to what extent does it actually relate to the dollar value of like the economic value of Bitcoin, or is it purely internal accounting? Because, or like related to itself, right? So, if you have a UTXO of 100 Bitcoin, the 173 sats per VByte is still not going to be a lot, regardless if Bitcoin is like worth 1 million or worth 100 bazillion trillion whatever. It's relative to the size of the in first instance it's going to be relative to the size of the UTXO, but and that is going to be probably the biggest factor in it determining the economic value of the transaction that you're doing. So moving
I don't know if
a lot of money.
you're buying a house and you wanna pay in Bitcoin, you pay a fee related to the price of the house. Like not like consciously or clearly, but in general, that's what will guide the amount you're willing to pay.
Yes,
So
I understand.
if one Satoshi buys a house, okay, so if one Bitcoin buys a house, whatever, you get what I'm saying.
Uh huh.
But I've heard an argument some time ago about how that was meaningless, and I don't remember the argument, but I think it's wrong. Yeah. Well,
Well, the
I think for now, at least, like every time the settlement byte number increase or decrease, it was related to Bitcoin prices moving and people
hmm
people wanting to to move bitcoins to exchanges from exchanges, right?
yeah,
And I
I agree.
and I think that was related to. Oh, I don't know what I'm saying. Okay, go on with your stuff.
No, but it's an important point because it this is the impact of like the $100 per UTXO number that relies on both price and the fee market, and it just so happens that both can move in the against you at the same time. So um, both the price going up and the fee market going up can happen at the same time, where in just one instant a lot of people are going to be shut out of or out of the Bitcoin network. And so for some reason fiatjaf is recording in a daycare. I don't know why. I don't know why. um,
Jesus Christ.
there are no cars on the street anymore. There are only toddlers on the street. So in any event, that can happen at the same time. So in one instant, like your entire global south meme is just destroyed because no fucking way in hell. Like normal people, I think $100 for like
What meme?
a minimal
I did
unit
never
of
did any
accounting.
meme using these words. Global South. I think.
No, not you. I'm not talking about your meme, but
The
the
listener.
general people, the Twitter space stuff, the ethereal they.
Yeah.
Um,
Well, these people don't
uh,
know, but they need drive chain.
this was not planned here as an excuse to start talking about drive chains. Um, or not yet, at least. Um, so, but yeah, the theme market itself is interesting because
But what do you say about people
technically,
that will say, "Oh, Lightning fixes this"? Like you should put all these UTXOs on Lightning. Well, if you do that now instead of waiting, then you should do that, and all your life will be saved. Your money is safe because your UTXOs are on Lightning, and you can move them forever without paying any fee at all, basically.
so yes, so there are two things here. So on the one hand, stuff like Lightning puts off a little bit of the pressure of the on-chain demand, right?
Yeah.
That's assuming that you're doing the type of transactions you would otherwise do on-chain. I don't know how much of the volume on Lightning actually accounts for those types of transactions. I think it's like a lot of far smaller transactions, and there it's like you're cheating like a little bit of a trust model there, something we've discussed already. Um, but ultimately, it's not going to save you in the fact that your channel size still has to be big enough, right?
Hmm.
You're still going to have to do the proverbial $100 UTXO size thing, and still pay 10%
Yeah, I'm
and all
just
that
thinking
stuff.
that people could do that
Um,
today before the fees go up too much, and then
yes, okay,
use
but
that
then
forever.
that's like one half, and then the other half is when you have to close it, and you're still going to have to pay
Or
it.
you never close it.
Yes, but if you never close it, then it's bullshit, right?
Why? It's not.
Because no, because the
Okay, okay,
guarantees
I see, I see, I
are
see, I see.
are based on the fact that you actually are able to go on chain.
Well, so the point some people will make is that you're going to pay a fee that is like 10%. Uh, but if you do a million transactions and then you pay 10%, what was actually the average fee you paid in each transaction?
Yes. So then you can discount the fee over all those bazillion transactions. That's true, but you're still it doesn't negate the fact that when you are doing the transaction, you're still gonna have to the size of the UTXO still needs to account for the fee. So it only optimizes those who can pay the fee in the first place.
Yeah.
You need to meet the threshold first, and when you meet the threshold, then you can then stuff like Lightning optimizes your dealings, but you still need to meet the threshold. So that's what's going on over there.
Yeah.
And with the fee market, it's like
By the way, never
I
don't do that if you have a small UTXO. Don't open a Lightning channel now and wait for the fee rate to go up, because your Lightning channel will close next week against your will.
you're just gonna pay fees to the miners and not gonna get any
Yeah.
money.
What
Yeah.
if you open a channel to the miner and then everything you transact is already going to him anyway, so you can use that to pay stuff through the miner, and when you get no more fees on the channel, you just let it close and it will pay everything. Everything will go to fees.
With in regards to the fees, so the bidding war, the resolution of the bidding war can go very low, or high. Sorry, the resolution can go very high, and this is something we've already seen in relation to the fee market in 2017. The steps that it made in terms of like the sets per VByte, it was very crude, right? We went up to like the bidding war, the overbidding went really fast, and like wallets like okay, I'm just going to do like 10 sets per VByte more, or I'm just going to double it or whatever. It was really weird wallet behavior, and then you get like these really high fee spikes. And if you compare it with the fee market of the last bull run, the amount of VBytes in the mempool, let's say, was similar, but the sats per VByte price, the price that people paid, was way lower because the bidding war was far more efficient. And this bidding war can get like almost infinitely efficient. It can't, because you still have like some resolution you have to account for. But you don't have to bid up in terms of one set per VByte. You don't have to, like, if somebody pays one set per VByte, the next step isn't 2 sets per VByte. The next step is paying one set more than the other dude. Not one set per VByte, just one single set.
Yeah.
So it's not going in steps of one set per VByte. It's going in steps of 1.00001 set per VByte, let's say. So that can be a lot more efficient. The problem is that what is actually accounting for the congestion? And so there are different user groups, and let's say we have the big whale user group, and those are the people just that use Bitcoin to move large sums of money. You're not going to price those people out of the chain, right? Because they're able to pay whatever. And then you have these different types of user groups, and then we do get back to this, that it relates to some, like the economics, the actual dollar value, let's say, or the economic value of what you're moving and what people are willing to pay. If the large, let's just for the sake of argument say that the people who move large amounts of money account for already 100% of the on-chain capacity, then they'll just move the fee rate to whatever the number is that nobody else is bothered to use the chain anymore. They can just keep it moving it upwards. And if they only account for like 50%, then we have like this room of 50% of chain capacity where other people might fight and they do like this bidding war thing, and maybe this one user group gets in like a certain percentage, or then it's more like fluid. But if it's like if there is a user group that doesn't really care about the fees because it's going to be cheap regardless for them, then the fees just move up really fast, just in order to make sure that all the plebs don't even bother to use it anymore.
That's why you need drive.
Don't say it. He said it. No, but I think this is it's like interesting to think about. It's going to be more interesting to see, but it just there in that 50% group of like the UTXOs that I discussed, there's bound to be like a lot of people who are going to be impacted by this, who are going to pay like at some point like 10% or 5%. I think even 1% is still a lot if you have to pay 1% in fees. That's still not cheap. So, and it's not a lot in terms of like the Bitcoin that are accounted in the system, but it's probably going to be a lot of people that are going to feel this. And it's also going to be probably a lot of those people are completely clueless about this stuff.
Yes.
That's my assumption, but
yes, including all the people that are on Twitter saying that Lightning fixes everything. Yeah. And also people that hate drive chain. They don't know what they're doing. Well,
yeah. So this is my napkin math.
So napkin math.
Make sure, and the main takeaway is just make sure that your UTXO size is like at least what is it, 0.01, I think.
Yeah, I don't know why people should never do on-chain transactions that small.
No, but I mean 0.01 is not small.
It's 1 million satoshis. Yeah.
Is that a million satoshis? I guess.
Yeah, a million satoshis is already too small. I think people shouldn't do that. They should use a Lightning custodian.
But as a lower bound, right?
Yeah, a lower bound.
Like,
that's
at least a million, but preferably more.
Yeah.
Though because I think if you're going to say that the lower bound is actually 0.1, that's rough, dude. That's a lot of money. So what's the so the 0.01, that's now $300? Yeah. So a million sets around $300. Yeah, that's still a lot of people that's a lot of money for a lot of people. And that group of 0.01 is another 25% of the UTXOs. It's actually 23.5, but whatever. But roughly another quarter. And then the 0.1 group, that's about 16% of all the UTXOs. And then it starts to ramp up go down really fast. Next group is 7, then almost 2, and then we go to the 0.3, 0.03, etc. But yeah, just make sure that at least it's like a million sets, about $300 right now. That way you're at least sure that you can still spend it. And yeah, you're maybe when fees start to spike, you're going to pay 1% or more. Somewhere between 1 and 10%, who knows? But you're still able to use the system. You haven't actually lost your money, because if it's less, then yeah, you're wrecked. So that's the public service announcement based on the napkin math that I did to just get a sense of this stuff. Because, as we've mentioned a lot of times in this podcast before, is that whatever scheme you're using, you're still going to have to pay the on-chain fees. You cannot get away from that.
Yeah.
If you want to do some trustless fancy stuff. And otherwise, you're bound to do something that is at least somewhat custodial.
Yeah. Which is how we should do. Or we should get Directchain. But yeah.
That's still custodial to some extent, right?
Yeah, I don't know if you can call it custodial, but
it's at least not as trustless as like other schemes are, as autonomous and trustless as other schemes are.
Yeah, that's true.
And of course, right, there are optimizations, and you can batch
Well,
payments.
we're already considering batching.
We can do
your calculations are based on complete batching, right?
Yes, correct.
Yeah.
Yes, that's true. That's true.
If we only had one
yes,
UTXO, what about that? We only have one UTXO in the entire chain, and we just move that, and we have the entire block space.
Yeah, then it's like double. So then it's like double the V bytes.
No.
you'll pay in.
If we only have one UTXO, we can only make one transaction per block, but then
Yes.
we move that transaction, and then all the transactions happen. Yeah.
It's like the Great Migration. Who's going to pay the miners with what?
No, I don't want to think about that. But I was thinking about this.
Or maybe
People that want to do
that
that ZK roll-ups thing. I think they imagined something like that. You have one UTXO moving around, and then you have some ZK magic ensuring that people can withdraw from that. But if they withdraw from that, where are they going to? Like, there's nothing. Yeah, that's that.
Yes, but if you take things to the extreme, they become silly really fast, right?
Yeah.
So, but just to give you some idea, it's like, okay, just paying for your own input, that's 57 and a half V bytes. The output is 43, and the overhead is 10.5, so it's 111 total. That's the most optimal type of transaction you can, the smallest type of transaction you can do currently. Is 111.
Okay, I think
bytes.
I am already getting lost with all these numbers, so I think people are already not listening.
Okay, just make sure you have your minimal UTXO size is at least a million satoshis. That's the point.
Yeah.
All right, and if it's not, you don't belong on chain.
Yeah.
Bitcoin's not for you, right? Okay, maybe BTC, the accounting number thing, might be for you. You can use you download wallets of Satoshi and you use that or something. I don't know.
Yeah.
Whatever it is, you use an LNbit server of some friend. Maybe go back in time and use LNTXbot and lose your money that way.
No. You can withdraw
Whatever,
your money.
but
yeah, you can withdraw.
yes, because there's some sweet little lady actually helping you do that.
Jesus Christ. Well, I am the one doing the withdrawals. This sweet little lady, I don't know what she's doing.
She's there. She's your customer support, fiatjaf.
Yeah, I asked her why is she doing that. She just said she wants to do it.
Because she's a sweet little lady. You should send her flowers or something.
Yeah, I don't think she's a lady. I think she's something else. I don't know.
Yeah, obviously it's like some fat neckbeard dude, right? Because there are no sweet little ladies on the internet. It's like a cave troll or something. We don't know, but yeah. So that was my prep.
Well, we
Um,
already filled the
I
entire
think
episode.
I think that Bitcoin. So the reason I started out with the first question is that we're in this, right? We're looking at Bitcoin continuously. We see the small incremental improvement thingies. But what's it like for the complete outsider that only interacts with Bitcoin on these
I think the
signal
order.
moments of like the bull run,
Mm.
right? How has Bitcoin changed for those people? If you're just look at it once every 4 years.
I don't know. I don't like to think of Bitcoin as like these cycles. People will talk about that just because they've seen the cycles in the past, but doesn't mean we will still have cycles forever. At some day, Bitcoin will.
Yes, but that's not the point, fiatjaf. The point is that
Okay,
at this
I know
moment
that
we
wasn't the
still have the
question. Sorry.
cycles.
Yeah, I know. Uh, I don't know. I don't understand why people are doing what are these people? Why are not they in Bitcoin yet? I don't understand. I re-
because they don't have because they don't have enough money to have at least a million satoshis in a UTXO
well, a lot
token.
of them have, and they're still not in Bitcoin. Yeah.
Well, they're getting into Bitcoin now because they can buy the ETF from BlackRock. Or I think Hong Kong. There was some message about Hong Kong stuff.
There
Bank of
there
whatever.
are other ETFs. I think that even Canada has an ETF, and that hasn't moved the
Hmm.
price at all. It's only the US that does stuff.
In any event, so yeah, I'm not sure that what I've discussed here right now is going to be relevant next cycle, but it's going to be relevant at some point.
Yeah.
So because there is probably going to be a point where fees don't go, the mempool doesn't clear anymore, and fees don't go for to 1 set per vbyte.
And what's your
Because
solution?
otherwise you
What's
could
your
just
solution
wait.
for buying coffee when we get to that point?
What my solution would
Yeah,
be?
for buying coffee with
No,
Bitcoin.
there is no solution. It's just a fact of the system.
Yeah, but we still have to buy coffee. Not me, I don't drink coffee. But people use this name. Me.
Yes. Okay. Um. Yeah. Custodial lightning stuff.
That's what your answer. Okay.
No, so it's not even custodial lightning. It's just like custodial Bitcoin, and then the custodian uses lightning. But the fact your channel is completely virtual, right? It's just a silly accounting trick because there's no way that you can actually open the channels, right?
What do you
With all these
use
customers.
to buy beers on your Bitcoin meetup that has the lightning stuff?
Um, I think I've tried everything. I've used LNTXbot a couple of times.
That was the best choice.
Uh,
I
yes, that
love
was
I
indeed
love
the best
that
choice
bot.
because then I used it. I just had to open Telegram and then like take a picture of the QR code and then it would read it and it would work. Yeah, it was great. It actually worked. So yeah.
Well, it didn't work for
Um,
me. I think my camera was very bad. So I used whenever I had to do that, which wasn't many times. I used like another QR code scanner, and then I took the output of that and pasted on Telegram.
let me think. Yeah, I've used a couple of things. I don't. I'm not sure if I've ever used. No, I don't think I've used my own node because I had my own Lightning node in 2018. So I don't think I ever used it on that meetup.
So yeah, that's part of what I'm saying. Like getting people are living Lightning. Normal people like you and me. I used to have two nodes. Now I only have one, but I want to shut it down. I don't want to do that anymore. I prefer
Yeah,
to use
well,
a custodian, but I think we should do a better thing instead of just using custodial lighting. We could have a better trusted solution. But yeah.
maybe. I don't know. Um,
Okay, I have another topic.
yeah. Yes, okay, what's the other
If
topic?
descriptions. Have you seen that? Oh, maybe we should talk about my tweet about the computers. Now that
Ah,
now
okay.
that no
Well,
one is listening
let's go
anymore.
to your.
Or if descriptions. Check the link I sent you. Someone copied
You sent me something.
someone copied inscriptions into Ethereum.
To Ethereum?
Yeah, as if Ethereum already didn't have a million NFT streams. And the inscription stuff is just made in the most dumb way. It's just copying the original stuff. And it is not even compatible with all the other NFT stuff that they had. They had standards of how to transfer NFTs, and the wallets implemented
Uh
that.
huh.
So they made a new thing called inscriptions, trying to capture the hype of ordinal inscriptions. And it's not compatible with all the rest of the Ethereum stuff. I don't understand what these people are doing. It's just a money grab or something. I imagine. How to transfer inscriptions. They can't do the ordinal stuff because they don't have a Satoshi moving around. They only have accounts.
Right.
So I don't know how they
Right, that was going to be my first question. Is like, is that even possible? Because they have like an account based system, and that was what I was thinking of. It's like, can you even follow that stuff with an account based system? Maybe, I'm not sure. Okay.
Oh,
You really want to talk about
you
this?
make the inscription, and then you get the inscription ID, which is the transaction ID that created the inscription, and then you make transactions of 0 Ethereum to the other account, and you include the inscription ID in your transaction data somehow. That's how you transfer the if scriptures. This is so stupid. Okay, next topic.
Okay, so we're gonna talk about computers.
Okay. Or we can end the
So
podcast here. Okay. Let's talk about computers.
so it's your tweet. So go ahead.
Well, someone posted a video of a computer from the year 2000 running Windows NT, but then he did the same computer running Windows 2000, I think, which is after NT. And in both cases, all the apps open instantly. Like he clicks and the things open in the screen. And today, all the apps, they take a while to load, and then they load the loading screen, and the thing that starts spinning. And after 5 seconds, 20 seconds, how many seconds you want, then the app shows up. That's the tweet.
So it's I think this is a fascinating subject. Um, no, I do think it's fascinating because it's like, okay, what is actually going on here, right? I've sent you the mother of all tech demo video thing.
Yeah.
Didn't we discuss this on the podcast already?
No, we did not.
Oh, okay. So there is this clip of a tech demo of what is it,
A
1964?
clip is a 90-minute video.
Yes. Okay. It's a 1.5 hour presentation. Yes. It's a 1.5 hour presentation of, I think it's a, so the subject is user interfaces, I think. I'm really going off memory here. And I think it's 1964.
1968.
And it's from, oh, 1968,
Yeah.
excuse me. I think it's from the people who also invented the mouse as a concept and the tool to interface with computers instead of just typing. And they are giving a demonstration as to what is possible with computers. and they basically show everything. So it starts out with you can type something, and then you can select stuff, and then you can copy it, and you can paste it, and you can cut, and you can put it into rows, and then you can copy rows, and you can sort the rows, and all the basic data manipulation stuff you can do. And then somewhere later on, they start to interactively work on the same document. So there's another dude on another computer in another room, and they work in the same document at the same time in real time. And then they're like, okay, well, let's have a conversation. And then they have like a voice conversation while they're working in the same document. And then they're like, oh, maybe you want to see each other. And then they also have like a video. So they basically have a video call while they're working in the same document. So this is like the Microsoft Teams stuff, or whatever the package of software tools you're using to do these type of things in 2023. And they did that in 1968. And it's kind of mind-blowing because there was a very long time between that point of 1968 and actual like graphical user interfaces like Windows that we know, and then even a longer step to where we're actually massively using these types of utilities on computers. So then the question comes up, is like, what happened? Why if a couple of guys can make a 1.5 hour demo decades ago doing all this stuff, and did it take so long for it to be there now massively for like a mass population? And why does that software suck, right? Because Microsoft Teams just sucks. It's absolutely horrible. It's slow.
Well, but there are better things than the Microsoft Teams, I think.
Whatever, but Microsoft Teams is big.
Okay.
A lot of people, a lot of businesses, a lot of people use Microsoft Teams. So, well, what happened? And this is in the same vein of like, why is software so shitty?
I don't know. I think that the explanations are different. I think the explanation you gave for why it took so long to do these things, to have these things today, was that mostly that thing was like hard coded to that demo and scaling that to multiple developers in a different, in not a well controlled environment, in a way that's like there is separation of labor. Like some people can work on the operating system and other people can work on the platform, that kind of stuff, and that's and like multiple programs can do similar things, and there are a lot of programmers instead of like 5 programmers doing all the things, the same thing in the computer design for that, and that thing takes a while maybe, and also the result is not as good as it could be if it was the folks that work. But also the result is also much more flexible. These are the things you said, right?
Yes, correct.
But that doesn't explain why apps take so long to load today and they did not in 2000.
It does. Because it's an increase in overhead due to an increase in abstraction layers. In order to facilitate in every wave of facilitation of new programmers and stuff is the introduction of new abstraction layers, which just increases overhead. I'm sometimes when I'm like half asleep and I'm dreaming, I have like these Tron type dreams of like you're in the circuit. You know the movie Tron, or the story Tron? Do you know it?
No, I didn't watch that.
Oh. Okay. Well, anyway, so it's like you're inside the circuits of the computer, right? Of the CPU. And then I'm just trying to imagine what these compute cycles actually consist of, and like how many fucking useless compute cycles are actually occurring to do some super basic function, right?
Yeah.
And if and you're at that scale and time slowed down because we have like clock speeds of, let's say, 3 megahertz or it's gigahertz, right? Is it gigahertz or what megahertz? How many hertz is it? What's the
I don't know.
clock speeds are at gigahertz, right?
Yes, they are. Yes.
Yes. So it goes like at 3 gigahertz. That's the clock speed of the computer, and you have like. But if you would slow it down and it would be like 1 hertz, and you'd experience that, and it took an age to just do like a simple addition, and you can see like these transistors changing state, right, every clock cycle,
Do you have these dreams?
and you can just yes, and then you can just see that it's actually doing fuck all, and it's just it's like they're just changing state, but they're not actually doing the thing that they're supposed to do, and it's like happening in this very convoluted way in order to eventually do the simple of addition of 1 + 1 is 2, right? And that is what is occurring inside of your computer at breakneck
Yeah.
speeds over
Yeah,
and
yeah.
over and over and over again. But it's just so fast that we do notice because the programs are actually loading slower than they used to,
Yeah.
noticeably. But yeah, that's I guess that's what's occurring. It's just more levels of abstraction, and there is some bullshit involved. So you have like these low code platforms. Are you aware of them?
Yes.
Yes. So, and the sales pitch of low code platforms is to like the managers and whatever people who don't actually understand is that it makes programming easier. So now everybody with a heartbeat can do like 3 weeks of training, and now they're a useful programmer.
3 weeks.
Right.
I think if 3 weeks of
Yeah,
training,
whatever.
you become the best programmer in your.
Yes, okay, it's like 3 hours. So after 3 hours of training, of 3 hours of tutorial, then you're like a rock star programmer, right? Your productivity is like times a million
Well,
because of these low code platforms.
no, but I think
And it's-
that's okay. I think that's okay if you want to do a small tool for you or for your company, and things that won't be used a lot. But when the stuff goes through like programs that are going to be deployed to millions of people, I think we should have more like performance aware programming stuff on that. But I think we don't. Like, I think the programmers that had more than 3 hours of training, they apparently know what they're doing, but actually they don't. Actually, they're writing code that is completely inefficient.
Yes, so that's the point that I was trying to make, is that it's a lie. So the low code platforms are fine because they can actually accelerate the productivity of a good programmer, right? If you're a really good programmer, you're probably a lot more productive inside of these low code platforms
I'm not sure about that.
than you would be if you.
I don't know. I'm not sure about that because you have to learn that too. Like,
Yes, but once you've learned it and you've mastered the tool, let's say,
yeah, I think it can help in some cases, but not in all cases. For some things, you have to go to the actual operating system or something.
but do you know the game Rollercoaster Tycoon?
Yes, I do know.
Yes, so that game is entirely written in assembly, apparently.
Jesus Christ.
And it looks great.
Yeah, I think most
has,
of
like,
the
this
games
iso-
from that time or before that, they were written in assembly. Yeah.
No. It was the programmer. He was an assembly
I
programmer.
guess this one is too
But at the
late
time-
for what I'm talking about. I think with in the
Yeah,
80s
so,
and low 90s, maybe they were assembly.
Yeah, correct. But this was later, so it was only because he was like an assembly programmer that he still bothered to write it in assembly. But at that time, it already passed on to like these software languages, and compilers and stuff. No, so, and it looks great. It's like this isomorphic perspective, so it looks kind of 3D-ish, and you can switch perspectives actually, so you can alternate to the 4 perspectives on the map, and every visitor of your theme park has like its own emotions and preferences and pocket money and own behavior and routes that it walks and all this type of stuff. It's very complicated. It's very sophisticated. Looks great, and it ran like a motherfucker. It ran on every fucking computer out there at the time. Every computer could run Rollercoaster Tycoon. Is there an air raid going on? Is Brazil being bombed?
Might be.
Do we have to call the special forces?
Yeah, send the money.
Is there murder happening? There's murder happening on the streets. Is there a hostage situation? What's going on? So no, so the question the reason that I bring it up is like you're saying is like, okay, it needs to be, or you can be aware of efficiency.
Transport Tycoon is also within the same way, right? Probably.
I think so. I think it's the same guy, right?
Yeah.
Yeah. But like, what is the answer? Is the answer actually writing everything in assembly?
Well, I don't think the. Well, I
Like,
think
fuck assembly.
we can
fuck,
see.
fuck
I think we
CPUs.
can.
No. Like,
Yeah.
fuck CPUs. Everything needs to be written in hardware design languages. Everything straight down to the metal. ASIC.
Well, my point is probably just that we need, like, because people worry about the UX of the program, so they try to make it look good and they try to make the best loading spinner they can find. So people, while they're waiting for the program to load, they look at a pretty spinner, but they don't think at all about making the thing a little faster. And I think that improves the UX much more than making a button flash when you click or whatever. Because these things also add to the overhead of clicking.
Yes.
Yeah. You want the button to do something. Yeah.
So this is one aspect that we didn't talk about. I think that's also very significant is just sheer resolution of things. So like graphics, right? You cannot get around that. I mean, things are bigger, files are bigger. That's the stupid thing with video games. Like they're tens and tens of gigabytes.
Yeah, that's
and
true.
that's mostly just because of the assets and the graphics involved and the resolutions that it has to account for. So yeah, okay, that's also an aspect probably that contributes.
That's true. I had
to the things that you have fancy buttons.
Yeah. Yeah, but I think the fact that computers got faster should account for that, right?
For the most part, yes.
Yeah.
So this is an interesting thing with so as you gave a this is a very interesting listening experience for our audience. So you gave a bit of a summary of what of what I already mentioned on this topic in the chat before. It's like you have to account for all these programmers and coming in and making it easier and like these layers of abstraction and overhead and stuff. Shit, now I forgot what I wanted to say. Yeah, I forgot what I wanted to say. But I do have another aspect. So I'm not a programmer. I cannot even write a single line of code in any language. I cannot hello world for the life of me. So my question to you is, if you look at what the capacities are with ChatGPT, I don't know, have you played around with ChatGPT before? And
yes.
Writing code with
yes, I did.
Writing code with ChatGPT. Okay. So on its own, it's probably not good enough, and you probably need to have some interface with an IDE. But once you have that, why not just write everything in assembly?
Well, I don't know. I don't think we will ever get to that point. But if we do, I saw some people like what's that guy from Wolfram Alpha?
Yeah,
that guy was saying this that all computing no one will write stuff low level optimization stuff anymore because we can delegate that to the AI. But I don't think we'll get to that. But yeah, that's an interesting idea. Maybe like you write some
No, but so
code, you can write some code that is, well, what compilers do is actually translate what you did to assembly.
yes, but now it's like on steroids, right? So now you're just writing natural language, describing what the functions ought to be, and then you're not even throwing it through a compiler anymore. You're just the thing writes it in bare assembly.
Yeah, that could be a possibility. That's a compiler, right? But it would be a much more intelligent compiler.
Because you're not restricted to the problem, I guess. It's very interesting because I've like, why am I talking about this shit? What the fuck do I know? But I guess there is, because you're within a programming language, it's like formal and constrained. So you have these contrived translations of what is the syntax you're using in writing the code, and then the compiler translating it to machine language. That there are some inefficiencies there that you don't have if you would actually translate from natural language and then writing it in assembly from scratch.
What happens is that when you write on a high-level language, the compiler doesn't know what you're trying to do, so it has to account for all the possibilities. Like, for example, if you have a garbage collection thing, that means you're writing on a high-level language. You're not managing memory, so you have to run something on the side of the main stuff you're writing that tries to keep track of memory and has to account for all the possibilities of where do you want memory and where you do not want the memory anymore. So it tries to get the memory back, and that's a lot of overhead. And there's also the typing stuff, like you don't know the sizes of when you're writing a high-level programming language, you don't know the sizes of the variables, you don't know the types of the variables, and you need like some interpreter running on the side, and that has to try to guess all the time what are the types of these things, the size of the variables, where on earth on the memory everything is. And if you did it on assembly directly, you would specify that directly on the code, and you wouldn't have to have these side processes keeping track of all the little mistakes you could have made, because the AI could write everything directly on assembly, knowing your intentions and knowing ahead of time what are all the possibilities that you want, that you have in your anyway. I think no one is following.
Yeah. So so that's the hypothesis, right? And then you probably have to do some iterations in order to specify it more, but that would be the hypothesis that going on.
Yeah, that's a good idea. I think this podcast has innovated in something. Yeah, but I don't think the AI can do that. I don't think.
Well, I don't know. It's like the ChatGPT that you're using is not optimized in writing assembly, right? But you can optimize it in writing assembly. You can just use the model you have right now and then add to it.
How can you check?
And then
if it's doing correct things.
You run the code. You run the code.
Yeah.
And you run tests on the code.
Yeah.
You do all the stuff that you'd normally do, and you can create an IDE. So you create a developing environment that has like the formal rule sets and some strictness to it in order to do the assembly stuff, but the AI is just an interface for your natural language and the formal environment of the IDE. So you no longer have to function within the formal, strict syntax environment of the code anymore. That's what the AI does for you.
Yeah.
And you just ask it, it's like, okay, write tests for all these subcomponents that it actually does what I want it to do. And run them and see if it actually does that, and
And you still need a high level of
make sure that the
language.
comments in the code are like sufficient and etc. Something like that.
Yeah.
And then the next question I have is, then does it make more sense to go to a risk environment? It's like on an instruction set level, like go to like risk environment where it's like you don't specify a lot of instructions, you keep it simple, and it's compatible. Everything you do is just compatible with everything, or you're going like hyper specific and go x86 on steroids, because you're able to actually use, or the AI is smart enough to use all these different opcodes that are available to you.
Yeah, I think you can do that. Right? And then you do a different build for each system, for each device.
Yes, so you can just specify, it's like, I have this computer,
Yeah.
create the code in such a way that it just runs on this system. I'm not sure what way is logical, because I can see some sense in both. But then again, it's like, if you ask me, we can just destroy CPUs entirely. What's the point of CPUs? Seriously.
Well,
Like, why have a Van Neumann architecture if we can just specify everything?
you end up
We no longer need
recreating
the
a
general
CPU.
the universal.
Well, you end up recreating something that, for example, such that you can run these tests. You need the test in a understandable language, so you can check if the thing is working. So you still need a high level language to write the test.
Yes, but then we're using the so we're using the CPU and the high level language as a staging ground, and then we move
Yeah,
off
for
of
the
it. And
normal
then
people, for the
we're
users, you
we're
can
just
get rid of that probably.
so then we no longer need to use. So
That's where we get
are
to
we
the
going
the
more
science
universal,
fiction.
or
That's where we get to the
are we
science
going to?
fiction scenarios where there are programs everywhere, everything works. Like everything has. Because if you imagine that today, imagine someone making those visual things that you touch with your hands and things move. Those things would be. We had so many bugs on them, and would need.
There's no input lag or anything.
Yeah, I think that's only AI that can program these things. If we try to do it today, it would take such a huge amount of work, and it would still have bugs.
So there, you got a blue screen of death on your hologram stuff.
Yeah, I remember that. I remember that Google Glass ad that they did. You remember that? That they was like a guy waking up and having the coffee, and the Google Glass would say a bunch of nice things. Everything would work. The guy would leave his house and do something, and would have a nice song playing. And then they did one with Windows, and the glass just showing errors.
Although I have to say, it's that Windows has become a lot less buggy for a long time now.
Except for playing StarCraft. StarCraft runs better on Linux now.
Maybe. I don't know. I have most of the problems with Battle.net, to be honest.
Battle.net, you mean
There's
that's
some weird stuff
that's
going on.
external app that you have to run in order to.
No, it's if I join a game, I have to wait. Sometimes I just have to wait like a minute before I actually enter the lobby. No, I have to wait half a minute before I enter the lobby, and then when I've entered the lobby, I have to wait another half a minute before I'm actually there, even though it shows that I'm there. Because you guys are like, oh, he joined. It's like, why is he not moving himself to observer? Why is he not picking a race? It's like, well, because I'm not actually there.
Well, on my Linux, it doesn't have that problem, and also the Windows computer that I used before is Windows 7.
I think it's because I'm not.
Windows 7.
I think they're throttling. I think they're throttling everybody who's not running remastered.
I really, yeah, it could be.
I think that's what's
There's
happening.
one
They're
of
like,
the guys
fuck
was
you,
not
pay
running
your 10
remaster.
bucks.
So I'm going to buy a remaster for you. And then I get rid of the favor I owe you because you bought the microphone. Actually
Is
I don't
that how
know.
you want to
I don't
settle
know
it?
if I'm using the correct microphone now because I think the sound is coming from the headphones and not from the table microphone. But I don't know how to check
So
that.
you're not using the right mic?
I think I'm not.
Okay, you can just see where it gets the input from in Audacity.
Well, it's saying audio 1.
Oh, yeah, that's very useful. Okay, well, we'll see what the sound quality is like. At least we had a very interesting dynamic ambiance.
Yeah. Well,
There was a lot going on.
it's the same.
People
It's
got
the same
murdered.
setup from the last week, so should be as bad as usual.
Okay. All right. Well, we'll see what the future of information technology and computer hardware and systems will have for us. The most important thing is make sure that at the very least have 1,000,000 satoshis in your UTXO.
Yeah. And never open Lightning channels. Just use a custodian.
Okay.
Okay.